Welcome back to Mrs. Thompson's classroom. Today we're going to be talking about the properties of functions. In particular, we're going to talk about finding the intercepts of a function. So that's kind of a review from last time. And then we're going to talk about when they are increasing and decreasing and constant. And then I'll have part 2 of this video, which will be talking about finding their mins and maxes and the symmetry of functions. But before we really dive into that, let's just take a look at a picture. Let's review those intercepts and define some other things. So x-intercepts are the intersections with the x-axis. So that means the y value will be 0. So for this graph, that occurs in 4 places. And I'm going to name them as points. So that first one's at -3, 0. And then I have one at -1 and at 1. And then the last one is at 3, 0. Now the y-intercept is where it intersects the y-axis. Now if it's a function, it's only going to have one of these, because for every x, I can only get one y. So when x is 0, I can only get one y value. For this function, that looks like it's about right here. So I'll estimate that, and we'll say it's at 0, 4.5. Okay, that's an estimate. Okay. All right. Symmetry, you may remember, is sort of if I can fold the graph in half. So like your body has bilateral symmetry because you could fold yourself in half. So we talked about symmetry on the y-axis, the x-axis, or even about the origin, which is sort of a rotational symmetry. For this graph, I could take any point, and I notice that that point gets sent to itself on the opposite side. And so we call this one symmetry about the y-axis. Okay. All right, minimums and maximums. These occur where the function has a valley or a mountaintop, a peak. Okay. And these, what we're really talking about here, are what are called local or relative mins and maxes. And this graph has some of both. This top point right here would be a relative maximum. Okay. And then down here at the bottom, we have a valley on both sides. And we're going to approximate that. It looks like it's at approximately -2.2 and -8. And then at 2.2 and -8. And again, those are approximations. Now, sometimes the question may just ask you to find the x. They may just ask you for what value does the function have a min or a max. Or the question may ask you what is the minimum or maximum value. And then it's talking about the y. So there's a where does it occur, which is either the x or the whole point, x, y, or what is the minimum and maximum, that's asking for the y value. So really listen to the way the questions are worded. Okay, domain is again the set of all x values. Okay, so let's take a look. The x values, if we're going to assume these curves keep going forever, up, that also means they keep going forever to the left and forever to the right. So this would be all real numbers. So we could write it in interval notation this way. Okay, for the range, I'm going to, looks like I've got this sort of bottom to the curve here, and then it keeps going up forever. So our range is going to be the y values such that y is greater than or equal to that bottom. And the other way to write that would be from -8 up to infinity. Okay. All right, so the big part here from reading the graph is to remember how to find the x-intercept and the y-intercept. We're going to get a little more into the symmetry and the mins and maxes in the next video. All right, so here's some more things about reading a graph. Now, we don't have the graph there yet. Now we're going to find some information and see if we can figure out what the picture is going to look like. We're going to go the other direction. So the first thing is 110 a point on the graph? Well, that simply means I want to take and find f of 1. Well, f of 1 means I plug 1 in for the x's, so I get 1 plus 5 plus 6, so that's 12. That is not equal to 10, so the answer to the question is no. Okay? Find the x-intercepts. Remember, this is the points where the function equals 0. So I'm going to take x squared plus 5x plus 6 and set it equal to 0. Well, this is a quadratic. We can easily factor this one, but you could use the quadratic formula. And if that factors, then each factor has to equal 0. So my answer is x equals -2 and -3. That's where the x-intercepts are. And of course, you can write them as points. Okay, the y-intercept is where the x value is 0 and we get a y value. So I'm going to simply plug in 0. And we get 6. So this would be at the point 0, 6. Okay? Now, find all x such that x, 6 is on the graph. Well, that simply means I want to take the function and set it equal to 6, because this is the y value. And so I'm going to take, that means x squared plus 5x equals 0, because I can subtract the 6 over. Then I can factor an x out. So this tells me x equals 0. And this one tells me x equals -5. So I have the points 0, 6. And I have the point -5, 6. So the answer to the question is at these two x values. Now let's plot all that information we just found. The y-intercepts are at -2 and -3. My y-intercept is at 6. And I know I have a point at 0, 6 and at -5, 6. And then I'm going to connect the dots. Now I know, or you may remember, that this is a quadratic equation, so it graphs like a parabola. So that gives me a sketch of what the picture would look like. And notice I have labeled a few points. I've labeled my grid. I can read that graph. Okay? All right. Now let's talk about increasing and decreasing. So first of all, we read our graphs from left to right. Okay? So this is going up and would be considered an increasing function. Whereas this one, notice I'm drawing it from left to right, and it is a decreasing function. Okay, and then if it goes flat and y is always the same, we call it constant. Now, not every function is always increasing, always decreasing, or always constant. Sometimes they do a little bit of all three. And so we want to talk about what it means to be increasing on an interval. Okay? So on an interval simply means that if x1 is less than x2, okay, so let's pick on our picture here an x1 and an x2. If we're increasing, then what's going to happen here? Well, let's look at the function values here and here. Okay, so this means that our function value will be related in what way? Well, if it is an increasing function, notice the x2, the bigger x, gets the bigger y. But if I'm decreasing, then that relationship is going to go backwards. Okay, so if x1 is smaller, then its y value is bigger. And if we're constant, then they are equal for all x1 and x2 in the interval. Okay? And so we can talk about what a function does on pieces. So look at this graph here. We notice on this graph here, the function is going up on the right, but it is coming down on the left, so it's doing both. So it's decreasing on one interval and it's increasing on another. So let's look at where it's increasing. Remember, all the way on this side is a negative infinity, so we are always going to use the x values when it asks for the interval on which the function is doing something. We're talking about the x values for which that's occurring. So we're going to go from negative infinity all the way to where it turns around. And that means it's going to be increasing from that turning point all the way to a positive infinity. Okay? Now in this curve, we're coming down here. We're also coming down on this side. So we're going to be decreasing from negative infinity to this turning point, which is at -1. And then this point here is at 1, 2. And so I'm going to also be decreasing from 1 on forever and ever. But what is it doing in between? Well, right here, it's going up. And so from this point to this point, we are increasing. And again, we're using the x values to denote these places. So the x values are -1 and 1. Okay, third example. So the red spot, the red part, is going up. So we are increasing from negative infinity to whatever this x value is. It looks like that's at -1. And it is an open circle, so I will not include that endpoint. Okay. Then the blue part is going flat, so that's constant. Okay. Now, those are endpoints there. They're dots on the end. So on a constant piece, I am going to include the endpoints if they're dots. Okay. And then finally, the green part, I'm coming down. So I'm going to be decreasing on that interval, which is at an x of 1, all the way to the right. Okay? All right, so next time we'll talk about extreme values and symmetry, but hopefully you can now go and get some practice on my practice worksheets that are on my website, which I'll try to link below, and that this should help you have a little bit of an idea what we mean when a function is increasing or decreasing. And I will see you next time.